Good afternoon, everybody. Welcome to the last session of our sub-presentation, and the presentations so far have been very interesting. So this is the ethnobotany session, session 1, and we've got 6 speakers that are going to finalize our sub-conference. Our first speaker is Unasia from University of Johannesburg, and she'll be presenting on special patterns and selection of medicinal plants in Southeastern Africa. If you're ready, Unasia, you can share your presentation and start your, you can go ahead and start.
Okay, hello everyone. I hope you're all good. Are my slides shared? Okay, thank you, Chair, for that introduction. So I am Unasia, and I will be presenting, as the Chair has, spatial patterns and selection of medicinal plants in Southeastern Africa. Culture is a mixture of abilities and habits that are obtained by members of a certain society, and it often represents a measure of how one group of people differ from others in terms of knowledge, morals, skills, beliefs, arts, law, and customs. All acquired capabilities in a culture are generations. Traditional knowledge consists of the history of a certain culture based on observations, experiences, and experimentations. It relates to the specific geographic area in the natural environment that has been developed by inhabitants over generations. New knowledge is continuously being added to the traditional knowledge systems, thus they are adapted from time to time. And adaptations in cultures may be due to the transfer of knowledge. Transfer of traditional knowledge can occur in one of two ways, either through horizontal transmission or vertical transmission. Transmission occurs as a result of knowledge being transferred from the ancestral to descendant culture, which is from generation. Horizontal transmission involves the borrowing and selective diffusion of another culture's traditional knowledge. It modifies tradition, sometimes the knowledge of an entire ethnic group. The modifications that occur due to horizontal or vertical transmission serves to keep and establish unique culture, yet preserving ancestral knowledge. The transmission of traditional knowledge therefore plays a role in the passing on of knowledge related to traditional medicine. Indigenous people to understand the use of medicinal plants as treatment of various illnesses, where the plants are located, how they are collected and prepared, and which plant parts are useful. A more practical example is on Monday when Prof. Ben mentioned during his plenary talk that they do ethnobotanical surveys in local villages where they ask 3 main questions, which is, do you know the plant? Do you know the vernacular name? And do you know the uses? And then they are in order to create a metrics method. So even today, indigenous knowledge is relevant as it is continuously helping scientists. Cultures that are in close geographic proximity are said to influence one another when it comes to the selection of useful plants. This phenomenon is referred to as Galton's problem or spatial autocorrelation. In a study in Nepal by Cyphylis Lukodakis, she revealed that spatial autocorrelation was not a main influence when it came to the selection of medicinal plants. Rather, it was the floristic environment that played a major role. This was supported by Dr. Welcome and Prof. Van Wyk on the selection of food plants in Southern Africa. Therefore, the purpose of this study was to determine whether spatial autocorrelation was significant when it came to the selection of medicinal plants in Southeastern Africa, or whether medicinal plants were selected based on available flora. The regions studied were Mozambique, Eswatini, Lesotho, KwaZulu-Natal, and Venda. These regions were selected based on availability of data floras. Furthermore, due to population movements, there are small groups throughout Mozambique, South Africa, and Eswatini that share Nguni languages such as Zulu and Swati, thus having similar cultural traits. Furthermore, these regions share similar vegetation types, which are the grassland, the Indian coastal belt, and the savanna, which covers most of the areas occupied by Bantu language groups except for the Sotho. 3 distance matrices were compiled. A distance matrix for geographic proximity constructed using the Haversine formula Earth for the coordinates of the 5 regions. Saracen index to construct the distance matrices for the similarity between the available floras and medicinal flora. The 3 were done, and the distance matrices to calculate the Pearson product moment coefficient and the corresponding significant value. The mental test was used to determine correlation using the vegan HR. Least square regression analysis was performed following the method of Moorman, where the available flora was the independent variable and the medicinal flora was the dependent variable. The following table shows the Pearson product moment correlation coefficient and significance of 3 correlations done between the different cases. It shows that spatial autocorrelation was not significant for the correlation done for geography and the available flora, since the correlation coefficient. There was also no significant correlation between geography and medicinal flora. However, there was a correlation between the medicinal and the available flora. It was strong, showing that the selection of medicinal plants between cultures could be influenced by the floristic environment rather than geographic proximity. These results further indicate that the plants were selected mainly due to the flora available. The R-square values between available flora and the medicinal flora in all studied regions were high. All regions had p-values that were less than 0.01, which was in further agreement with the correlations in the previous table. The figures comparison of the 10 most rich medicinal according to the number of available flora. The 3 largest families in all regions were the same, namely Fabaceae and Asteridae. Although the rankings, as you can see on the screen, were different, which were different for each region, except for the Venda region, among the 3 largest families, but had Malvaceae as the 2nd largest family. As previously mentioned, the habit types of these regions are predominantly savanna and grassland. Fabaceae and Poaceae are typical savanna and grassland families, respectively. The other 7 families are not distributed in a similar manner, or they are not the same. Even have similar vegetation types, they still have different floristic environments. Even though the 3 largest families might be the same, shows that the selected medicinal plants were different. The following table shows these used medicinally ranked according to the residual values. Families in green are overrepresented, and families that are in red were underrepresented according to the regression analysis. The families that were mostly selected were not uniform across all 5 regions. Some families that represented in one region could be overrepresented in another. For example, the Apocynaceae were overrepresented in Mozambique, Eswatini, but underrepresented in KwaZulu-Natal, and were insignificant in Lesotho and Venda. Furthermore, we can see that the Euphorbiaceae were overly represented in Eswatini, Natal, and Venda, but were not significant in Lesotho and Mozambique. The data presented here showed that no significant between geography and the available flora, or geography and medicinal flora, but there was a significant relation between the available flora and medicinal flora. This was not only seen on the Pearson product moment correlation, but on the high R-square values of all the regions. More results from the regression analysis indicated that medicinal families were not selected the same. Therefore, cultural similarities, ancestral linkage, close geographic proximity in this case were not statistically significant. Thus, to answer the question for the study, relation was not significant in the selection of medicinal plants. Medicinal plants were selected based on the available flora. I would like to thank you all for listening. I would like to thank SAAB for the platform, most of all my supervisor for the guidance, at the University of Johannesburg. Thank you. Okay. I will be listening for questions.
Unesia, for that talk. It was very interesting. I'm sorry about that. I think my internet is a bit slow. So
Okay.
are there any questions from the audience that you might be interested to within that talk? I just have a quick question here. With your results within the different families that you looked at and seeing the similarities, did you further go into looking at specific genus and species, if there's any of those correlation, or you were just within the family boundaries?
Well, for this study, I only focused on the families due to the amount of data that I would have to look at. Master's project, I did look at similarities between Mozambique and KwaZulu-Natal, and recently I've also done a comparison of Mozambique and South Africa, whereby I've seen a high percentage of similarity between species. It's just a matter of, it takes a lot of time. Hence, I did not do it for the study, but it's possible that there might be similarities among species, but I don't think it would be too like a big similarity. I don't think so.
Okay, I'm sure it will be interesting to know that, but I mean, you've done it in the past, because I know sometimes we heard a talk earlier on, it's just that I forgot who the previous speaker was in the earlier session, that even with the different families, when they start going within the species, then they see some correlation there within the different medicinal plants, and they also saw that some of the plants that were really used a lot in the Lamiaceae family were salvia and stuff like that, and some of those species. But that is very interesting. So I've got a question here from Marian. So they say interesting that the Phobiaceae are so much used, but generally considered as toxic.
To comment on that, a similar thing with the Apocynaceae, as we saw, they are actually used a lot in Mozambique, but they are considered toxic. So I think most of the time people would apply them topically, like on the skin, but I wouldn't know for sure until I actually look into that, because I also had a similar question in our previous conferences. But yeah, it is really interesting as to what people use for medicinal plants.
I'm sure it is. So also Adeyemi here has commented, says, well done on your great presentation. So he's asking, what is the significance of your findings on the broader communities?
Well, in this case, the significance of these findings, now it will into other things when we are doing ethnobotanical surveys, just gives like a broader overview of what to expect when you go out and do ethnobotanical surveys. Now you will have more questions like you asked, are there similarities between the families? Since we found that it's not the geographic proximity that actually relates, geographic proximity that makes similar selection of medicinal plants, we can look into other things like digging deeper, looking into the specific species used and cultures. For example, the Pedi and the Sutu, since they speak similar languages, is it possible that they also use similar plants? So it's useful to have such information when you're going to conduct ethnobotanical surveys. Now you know what to expect. You have like some sort of hypothesis to work on. Yeah, I don't know if that answers the question.
In my opinion, it does, but we'll hear if Adeyemi also adds a follow-up question on that. So Prof. Van Wyk also is asking here on the broader significance of the study in terms of the broader picture of African traditional knowledge.
Well, is quite limited. So in order to have like a bigger picture would mean we need to add more countries or cultures in order to have some sort of definitive conclusion. But for now, we understand that from what I've presented, that just because cultures live close to each other, it doesn't mean medicinal plants the same. So if we go and maybe add in more cultures, add the Cape herbal plants, maybe we will be able to see the significance of in a broader view, broader perspective.
Okay. So Marion has a follow-up comment or question here, which is from the previous question that was asked, is that, or are they used in low concentrations, the Euphorbiaceae family, since it's toxic?
I honestly don't know, because what's the word? Administer the plants or the actual uses, since I was looking at more air, but it would be interesting to read on that. There's a paper by Magwede for the vendor people. I know in his paper, he also included how the plants are used. So you might have an idea of if they are used in low concentrations or not, or how they are applied and stuff like that. And so I do not want to make any speculations. I really do not know.
Okay. Okay. Yes. Okay. So with that, thank you very much for keeping to time and us being able to ask you so many questions. Your talk was very interesting. So we hope to hear more if you are to go further into your studies and looking at some of the different questions that people might have commented on. So
Yes,
our second speaker then. Okay. So there we go. Our second speaker here is Tabiso from VERTS, and his presentation is going to be on comparative phytochemical analysis, antioxidant and antibacterial activities of the leaves and the grounds of bulbine. You can load your presentation and go ahead.
All right, thank you very much. Okay. But are you able to see my screen? Can you see my screen?
We can see your screen. You want to just scroll through to the next slide so we can make sure it's working?
Okay.
There we go. Okay.
Good afternoon, fellow ladies and gentlemen. As previously mentioned, I'll be giving a presentation on the comparative phytochemical analysis, antioxidant and antibacterial activities of the leaves, underground stems, and roots of Bourbania abyssinica. Bourbania abyssinica is a succulent medicinal plant within the Tlc family. It is characterized by its grass-like green leaves, small underground stems, and thick storage roots. Bourbania abyssinica is indigenous to South Africa, with the species being distributed across the Eastern Cape, Western Cape, KwaZulu-Natal, and Free State provinces. The species can also be found in parts of Lesotho, Eswatini, Angola, and Ethiopia. Bourbania abyssinica leaves are commonly used to treat skin-related ailments such as rashes, wounds, scars, burns, and acne. And the infusion of leaves and roots are known to treat chickenpox and administered to children. The species is also known to treat rheumatism, bilharzia, diabetes-related illnesses, as well as bacteria-related diseases such as dysentery. Uses, the species is also known to be used in ethnoveterinary medicine, as the leaves are fed to cattle to relieve them of gastrointestinal parasites. The infusion of the roots are also given to cattle to help cleanse blood, as well as treat internal sores. Medicinal plants, much like Bourbania abyssinica, are beneficial to multiple industries, such as pharmaceuticals, cosmetic, as well as food and beverage industries. And the commercialization of this species would not only benefit industry, but it would also boost the country's economy and promote job creation. To date, most research has been documented on the quantitative phytochemical analysis, antioxidant and antibacterial properties of the leaves and the homogeneous mixture of the whole plant of Bourbania abyssinica. And by homogeneous mixture, I mean the mixture or the combination of leaves, stems, roots, and flowers. This leaves a gap for studies on the underground stems and the roots, as research on these plant parts are very limited. In addition to this knowledge gap, the comparative analysis on the phytochemical and biological properties of the different plant parts of the species is also limited. This kind of research is imperative as it could provide in detail on the varying medicinal properties of the different plant parts of the species. Thus, the aim of the study was to assess the phytochemical profile, total phenolic and total flavonoid content, antioxidant and antibacterial activities of the leaves, underground stems, and roots of Bourbania abyssinica. Firstly, a qualitative phytochemical screening of the leaves, underground stems, and roots was performed. Secondly, the quantitative total phenolic and total flavonoid content in the different plant parts of the species was determined using standard procedures. Thirdly, the antioxidant activity of the different plant parts of Bourbania abyssinica was determined. And lastly, the antibacterial activity of the leaves, underground stems, and roots of the species was tested against gram-positive Staphylococcus aureus and Streptomyces albulus, as well as gram-negative Escherichia coli. For the sample preparation, potted Bourbania abyssinica plants were acquired from the Phytochemical nursery in Hartbeespoort in the Northwest Province. They were maintained and watered every 2 days in the greenhouse at Wits University for a period of 1 month. Once they had fully acclimatized, the plants were taken to the laboratory where the leaves, underground stems, and roots were harvested and rinsed with distilled water prior to being transferred into a hot air dryer set at 40 degrees Celsius for 4 days. Once dried, the respective plant parts were ground to fine powder using an electric blender and prepared for extraction. 3 grams of the respective powdered samples were mixed with 25 milliliters of 80% methanol. Then the extracts were placed in a sonicator bath for 25 minutes, which allowed for the proper breaking of cell walls and subsequent release of phytochemical compounds. Following this procedure, The extracts were filtered and the supernatants were retained and stored in the refrigerator, awaiting phytochemical, antioxidant, and antibacterial analysis. For the first objective, the extracts were used to identify the presence of 10 phytochemical compounds, whereby aliquots of the extracts were mixed with various substances depending on the phytochemical group being tested for. The change in the color or presence of a precipitate in the mixture would indicate the presence of the compound, and the darker the thicker the precipitate, the greater the quantity of the compound in the extract. For the quantitative phytochemical analysis and antioxidant activity assays, a spectrophotometric method was adopted, whereby the absorbance values of the extracts were recorded at varying wavelengths to determine the concentration of total phenolics and total flavonoids for the phytochemical analysis and the IC50 concentrations for the antioxidant assays. To determine the antibacterial activity of the leaf, underground stem, and root extracts of Bourbania abyssinica, the egg Mueller-Henton agar plates were cultured with the bacterial strains before transferring them into an incubator set at 37 degrees Celsius for 24 hours to ensure the full growth of the bacteria on the agar. Once the plates were covered with the strains, 6mm wells were bored in the agar, which were then added with 100 microliters of the respective extracts and 10% of dimethyl sulfoxide, which was used as a negative control for the study. The plates were transferred into the refrigerator for 2 hours to ensure the efficient absorption of the extracts in the agar before moving them back into the incubator for another 24 hours. This was done to determine whether the extracts would inhibit bacterial growth. Once inhibition of growth was observed, the zone of inhibition, which was indicated by the clearing of the agar around the wells, was measured using a ruler to record the diameter in millimeters. Staphylococcus aureus and Streptomyces albulis were both selected as they are commonly associated with skin-related infections. And E. coli is a huge concern in South Africa, as it is one of the leading causes of diarrheal infections and deaths. In addition, E. coli is also associated with urinary tract infections. Moving on to the results and discussion, we're starting off with the phytochemical screening results of Bourbania abyssinica. As I've stated earlier in the rationale, that only quantitative phytochemical analysis has been documented on the leaves and the homogeneous mixture of the whole plant of the species. To date, there is no record on the comparative qualitative phytochemical screening of the different plant parts of the species. As you can see that the leaves have the most presence of tested phytochemical compounds, with tannins, phenolics, flavonoids, steroids, and terpenoids having a moderate quantity, indicated by the plus signs. And the glycosides and the saponins were detected in lower quantity. For the underground stems, they showed a low quantity of tannins, steroids, terpenoids, glycosides, and saponins, whereas the roots had the same quantity and presence of compounds as the underground stems, with the exception of the presence of tannins. Interestingly, all three plant parts showed no presence of coumarins, probatinins, and volatile oils, as indicated by the red color. However, they did show a presence of steroids, terpenoids, glycosides, and saponins, indicated by the blue color, which these compounds are beneficial to industry. For instance, steroids can be used to treat eczema, as well as painful joints and muscles. Terpenoids are useful against inflammatory diseases. Glycosides can be applied in cardiac and liver medication, and saponins are known to lower blood glucose and lipids, and can also be used in platelet aggregating medication. These results further elucidate the importance of these plant parts for commercialization, as well as in traditional medicine and industry. The total phenolic content of Bourbania abyssinica shows that the leaves, again, have the highest concentration of total phenolics, followed by the roots, and lastly, the underground stems. However, both values of the underground stems and roots gauge very well with the leaves, meaning that they also possess a good medicinal activity. A significant difference was observed for all plant parts for the total phenolic content. With regards to total flavonoid content, a similar pattern as the total phenolic content was observed, with the leaves having the highest concentration, followed by the roots and then the underground stems. Only the leaves and roots, however, showed significant differences for total flavonoid content. The antioxidant activity results, or assays rather, revealed interesting results. The DPPH scavenging assay showed that the roots and the underground stems scavenged DPPH radicals much better than the leaves, with both underground plant parts presenting IC50 values lower than 1 milligrams per milliliter, indicating an excellent antioxidant activity. The leaves displayed a good antioxidant activity with an IC50 value lower than 10 milligrams per milliliter. Significant differences were recorded for all plant parts for this assay. The hydrogen peroxide assay results showed excellent scavenging potential against the radical across all plant parts, with IC50 values being under 1 milligrams per milliliter. The leaves have a slightly stronger scavenging power, followed by the roots, and lastly, the underground stems. For this assay, there was no significant difference that was observed. All three plant parts showed a good antioxidant activity against iron radicals in the metal chelating assay. The IC50 values for the leaves and underground stems are pretty much similar, and the roots had a slightly higher IC50 value. Again, there was no significant difference observed for the metal chelating assay. Although the underground stems and the roots had an excellent antioxidant activity against two of the tested radicals, namely DPPH and hydrogen peroxide, Bourbania abyssinica has an overall good antioxidant activity. This validates the uses of its plant parts in ethnomedicine and indicates their application in pharmaceutical and cosmetic industries for the development of antioxidant products. Lastly, with the antibacterial activity of the leaf, underground stem, and root extracts of Bourbania abyssinica, as previously mentioned in the methods section, the extracts were tested against Staphylococcus aureus, Streptomyces albulus, and Escherichia coli. The leaf extract successfully inhibited bacterial growth with zone of inhibition values of 19 millimeters against S. aureus, 17 millimeters against S. albulus, and 14 millimeters against E. coli. The underground stems showed a similar inhibition against S. aureus and E. coli at 15 millimeters for the leaves and the roots. However, the underground stem failed to inhibit any bacterial growth against Streptomyces albulus. The root extract managed to inhibit all bacterial growth, similar to the leaves, with the extract inhibiting Streptomyces albulus much better than Staphylococcus aureus and E. coli, which had similar zones of inhibition of 13 millimeters. Overall, Bourbania abyssinica plant parts showed an intermediate antibacterial potential against the tested strains, with the values ranging between 10 to 19 millimeters, with the exception of the underground against S. albulus. This means that the plant extracts do have antibacterial potential. However, their effects are not certain. The plant parts can still be used for the treatment of bacteria-associated infections. In conclusion, we have seen that the phytochemical screening results show that the leaves contain the most compounds and subsequently the highest concentration of total phenolics and total flavonoids. The antioxidant activity results with the underground stems and the roots displaying excellent scavenging activity against DPPH and hydrogen. Overall, Bourbania abyssinica has shown to have a good antioxidant activity. The antibacterial activity results showed that the leaves slightly outperformed the underground stems and the roots against Staphylococcus aureus and Streptomyces albulus. However, all the plant parts, with the exception of the stems against S. albulus, have an intermediate inhibition against the bacterial strains, showing that they do have potential for traditional use as well as industrial application. Future recommendations should include the isolation of compounds using advanced quantitative methods, such as high-performance liquid chromatography and liquid chromatography mass spectrophotometry, especially for the underground stems and the roots, since these plant parts are seldom studied. By doing so, the compounds can be tried against a variety of pharmacological parameters in order to determine their potential. Lastly, as we are aware that climate change is an unavoidable topic, especially to us botanists, as we are concerned about the impacts it has on our plant biodiversity. By conducting studies on the impacts of abiotic stress factors, such as elevated carbon dioxide, temperature, and drought stress on the phytochemical and biological properties, much like Bourbania abyssinica, we would be able to understand how the plants adapt to changing climate, how this affects their phytochemical profile and medicinal activity, as well as develop mitigation strategies to help improve sustainability and prevent loss of biodiversity. Thank you very much.
Thabisa, for that very interesting talk on the bulbine species. And we've got a question. Okay, sorry about that. My connection, I lost my connection there a bit. We've got a question here from Adeyemi, who has firstly congratulated you on your very brilliant presentation. And are you still there with us, Tabiso?
Yes, I can still hear you.
Oh, okay. So his question is as follows: given the difference you reported, what is the conservation implication of your results? Will you recommend plant part substitution?
Well, with regards to this species, in traditional context rather, it's been reported that the leaves are the most commonly used plant parts. So in terms of overall use of the plant, I would recommend a variation of the uses of different plant parts. However, in a conservation point of view, that might still need to be evaluated.
Okay. I think that question that Adeyemi poses, I had the similar one because I saw that also bovine, besides being just used in traditional medicine, there are also products that are available of it now. So for a conservation perspective, then if from what I saw in your results, it tends to seem that the leaves at times outperform the roots. So then it would be of better value to work with leaves that we know that they're sustainable for a long period of time, rather than always just having to harvest the whole plant within the conservation aspect of things. Since again, the stem wasn't doing as well as the leaves.
That makes a good point.
But yes, but that was very interesting. So there's another follow-up question. Oh, no, there's another question here from Oladayo, who also congratulated you on your presentation. And the question is, what is the rationale for the solvent used, which is your 80% methanol? Why not consider other solvent, polar or non-polar solvents?
Okay, so well, the reason why methanol was used as a solvent was most research papers actually use methanol because it's commonly stated that it has the best potential in terms of extraction of phytochemical compounds. However, yes, it would be a good recommendation to use other solvents, such as water, for instance, since it's the most commonly used solvent in traditional context, as well as try other polar solvents such as chloroform and hexane. It would be a very good recommendation as well.
Okay. I don't see any further questions here, and you've also kept to time very well. So thank you very much for that presentation, and all the best with your isolation and the rest of the project, future studies that you plan on doing.
Thank you very much.
Okay. So then our presenter is Tambuzani. Oh, she's available. So Tambuzani is from the University of Limpopo, and she'll be presenting on antioxidant and in vitro antifungal activities of selected traditional plants that are used in ethnomedicine. So you can load your talk and start as soon as you can. Sure. What is it? Are you able to share your talk? Okay.
I'm struggling to share. May you please share it for me?
Can I ask the technical team to please assist us? Checking.
Could you give me one moment? I'll open the slides quickly and just share them for you on your behalf. Okay, can I try and talk you through it quickly? I don't seem to have a copy with me. What do you see in front of you now?
I'm seeing SAAB
Is your
2020.
presentation open in full presentation? So what do you see in front of you now? There we go. There we go. Thank you, Jackie. Can you see your slides?
Yes, I can see it.
Great. Okay. Over to you. You can proceed.
Okay, thank you. As been introduced, I'm Machaba Chisi. The topic of my presentation is antioxidant and in vitro antifungal activities of selected traditional plants used in ethnomedicine. Next. Plants have been used as a source of primary health care by the traditional healers and the local people. The indigenous knowledge on the use of the medicinal plants relies on the elderly people, and the young people are less knowledgeable about the use of these medicinal plants. The bioactive compounds, such as the flavonoids, sterols, and the alkaloids present in the plants, possesses the antioxidant activity which defends the free radicals causing different diseases to humans. The fungal infections, more especially those associated with Candida albicans, Cryptococcus mufomans, and Aspergillus fumigatus, are the common cause of morbidity and mortality in the world. There is also an increase in the resistance of the fungal pathogens to the currently available drugs, and therefore the traditional medicine can be used to overcome the growing problem of the resistance of the antifungal drugs. Next. Next, okay. The aim of the study was to investigate the plant species used for the treatment of various ailments, determine antioxidant activity and antifungal activity against the fungal pathogens. The objectives of the study were to select and identify the plant species with antifungal activity against animal fungal pathogens, investigate the plant part used to treat various ailments by the traditional health practitioners, to screen the plant extract for qualitative antioxidant activity, investigate the phytochemical analysis of different plant extract, and lastly was to determine the antifungal activities of the selected plant species against Aspergillus fumigatus, Candida albicans, and Cryptococcus mufomans. Next. The plant material were collected from Makado local municipality, and they were allowed to dry before grinding for about 3 to 4 weeks. Then finely ground powder was extracted with solvent of various polarities, which is the hexane, dichloromethane, acetone, methanol, and water. And the solvent were removed under the stream of cold air. Next. For TLC fingerprinting, the chemical constituents of the plant extract were analyzed using the TLC plates, and then they were developed with different ion systems, which is the EMW, the BEF, BEA, and the CEF, wherein 10 microliters of each plant extract was loaded on the TLC plate, and then they were developed under those 3 ion systems. After developing them, then the chemical components were visualized under the UV light, and the chemical components that were not visible under the UV light, vanillin sulfuric reagent spray was used for detection. The antifungal activity of the plant extract were investigated against Aspergillus fumigatus, Candida albicans, and Cryptococcus mufomans using the microdilution assay method and then the Bio-Orthography assay method, wherein in microdilution assay, 100 microliters of each plant extract was serially diluted with 50% of water, and then acetone and amphotericin B were used as a negative and a positive control. Then 100 microliters of the three fungal pathogens were loaded on the microtiter plate. Then they were incubated overnight. After 24-hour incubation, 40 microliters of INT was loaded on the microtiter plate, and the results were recorded as the minimal inhibitory concentrations. Then for Bio-Orthography Assay, 10 microliters of each plant extract was loaded on the TLC plate, and then they were developed in EMW, CEF, and BEA. After developing the TLC plate, they were allowed to evaporate, the chemicals, they were allowed to evaporate for 3 to 4 days before the spraying with the fungal cultures. Then after spraying with the fungal cultures, they were incubated overnight. After incubation, the TLC plate was sprayed with the 2 milligram per mil of INT, and then the chemical components, the active compounds were detected as the white areas behind the pink background. And for Bio-Orthography, for qualitative DPPH, free radical scavenging, 10 microliters of each plant extract was loaded on the TLC plate. Then they were developed in BEA, CEF, and BEA. Then after developing them, the solvent were allowed to evaporate. Then after that, the chemical components were visualized under the UV light. Then after visualizing, the TLC plate was sprayed with 0.2% of DPPH in methanol. Next. These are some of the medicinal plants that were identified from the study. We have Clinia longiflora, commonly known as mobile, which is used to treat the chest pains and fever. We have Pessia americana, commonly known as avocado, which is commonly used to treat the ulcers. We have Dicrostachys cinerea, commonly known as morange, wherein is commonly used to treat the sore throat. And then we have Peltophorum africanum, commonly known as mosese, which is used to treat the stomach aches and the sore throat. Next. Next. This table shows the minimal inhibitory concentrations in milligram per mil of selected plants extract against the tested microorganism. We have acetone and methanol extract of Dicrostachys cinerea roots. They inhibited the growth of Candida albicans, Cryptococcus uniformans, and Aspergillus fumigatus, with the MIC ranging between 0.02 and 0.04 milligram per mil. We also have the acetone and methanol and water extract of Clinia longiflora. They've shown good activity against the two pathogens, which is Cryptococcus uniformans and Aspergillus fumigatus, with the minimal inhibitory concentrations ranging between 0.02 and 0.31. Next. We also have the acetone dichloromethane and the water extract of Peltophorum africanum. They've shown excellent activity against all tested microorganisms with the minimal inhibitory concentration of 0.02 and 0.08. Next. This is a figure shows the TLC fingerprinting of Dicrostachys cinerea roots, Peltophorum P. americana, and then Peltophorum africanum and Papaya capensis, developed in BEA. Then they were sprayed with vanillin sulfuric reagent spray. And then the one on the right is a TLC chromatogram of the same plants developed in BEA, and then they were sprayed with Cryptococcus uniformans. The white areas against the pink background indicate the zone of inhibition by the plant extract. And then more compounds were visible in P. americana leaf extract or in the dichloromethane in dichloromethane leaf extract of P. americana with the RF values of 0.44 and 0.58. Next. This figure shows the TLC chromatograms of Dicrostachys cinerea roots and Sansevieria hydrozoites developed in BEA. Then the left one was sprayed with the vanillin sulfuric reagent spray, and then the right one was sprayed with 0.2% of DPPH in methanol. Then on the right one, the yellow zones indicate the presence of the antioxidant compound, and then more compound were visible in Sansevieria hydrozoites with in acetone and dichloromethane extract with the RF values of 0.14, 0.34, and 0.70. Next. In conclusion, the indigenous knowledge can be used as a reliable source for the discovery of plants which deserve further investigation to validate their use by the traditional healers. All the plant extract tested show some varying degrees of inhibition, and then some water extract were highly active against the tested microorganisms, which support the use of the water as an extractant by the traditional healers. More antifungal compounds were visible in the extract of Dicrostachys cinerea roots, and then in future we'll isolate the antifungal compound of the most promising plant species. Next. I would like to acknowledge the traditional health practitioners, the NRF, and the University of Limpopo. Thank you.
Thank you very much for that talk. It was very interesting, and it's quite interesting what your water extract also gave the activity within them, because in most cases, at times when people do extraction, they find that the water extracts tend to not be very active, but it's very interesting with that. And as we know, definitely indigenous knowledge is very valuable in all these studies that we do within the ethnopharmacology, and it plays a huge role in when people go on and further go and test, because we already know where the starting or the basis of why we are testing those medicinal plants. So we've got a question over here from Adeyemi. He says, a nice presentation, Carol. Well done. So what influenced your choice of the selected fungal strains? What is the implication of the results? Okay, the first one is what influenced your choice of the selected fungal strains? And then your second question is, what is the implication of the results to the local communities?
Okay, thank you. The first one, for the choice of the fungal strains, we've searched, and then we've searched for literature, and then the microorganisms that we've used, a lot of work has been done on the study area, and then it was also the people, the fungal infections that, the fungal pathogens that we chosen, they infect most people who are immune compromised in the area, and then no study has been done regarding those microorganisms. That's why we've chosen those microorganisms. Then what's the implications of the results to the local communities? The results that we'll find, since the starting point of the project is we do the ethnobotanical surveys. So after getting the results, we'll go back to the communities and tell them the feedback. And it will also help us if we found something if you find the compound that are promising to develop a fungal drug, it will be helpful to the community because the drugs will be developed locally, so the communities will have access to the drugs, and then they will be they won't be expensive for them, and also since the plants will be accessible to the communities, if you encourage them that they should also use those plants, then it will be helpful for them to treat those fungal infections using those plants. Thank you.
Okay. Another question has risen here from Prof. Van Veek. So his question is, are you planning to publish the antimicrobial results soon? Or are you going to isolate and identify the compounds first before you publish?
In the meantime, we've wrote a manuscript on the preliminary results. Then we'll also publish the manuscript after isolating the chemical compounds that will be active. Thank you.
Okay, so it's going to be 2 manuscripts from this work.
Yes.
Okay, that's very interesting. Since there are no further questions, thank you very much. You've also kept well to time, so we're really on a good pace so far. So we can move on to our 4th speaker. So are you with us, Tuwani? Okay, there we go. So Tuwani is from the University of Limpopo also, and she'll be presenting on the South African medicinal plants that are used for the treatment of syphilis in Vembe district in Limpopo. You can load your talk and then get going when you're ready.
All right, thank you. Greetings, ladies and gentlemen. I am Trifina, introduced as Tuwani, and I'll be taking you through the South African medicinal plants used for the treatment of syphilis in the Vembe district, Limpopo province. The high rate of sexually transmitted diseases and infections amongst the youth in the deep rural areas of the Vembe district is quite alarming. Sexually transmitted diseases are infections caused by bacteria, viruses, or parasites, and are transmitted from an infected person to an uninfected person through sexual contact. Examples of sexually transmitted diseases include gonorrhea, chlamydia, as well as syphilis. Syphilis will be what we'll be solely talking about today, commonly known as Tusura by the Bavenda-speaking people. Syphilis is a systematic disease that is caused by the spirochete bacterium Treponema pallidum. Medicinal plants have been used for the treatment of human infections, especially sexually transmitted diseases, since ancient times. Now, this emphasizes the significance of indigenous knowledge, which is the unique and specific to a certain culture and is part by either the local people or by the traditional health practitioners. Knowledge and expertise related to the traditional use of ethnomedicinal plants may offer a significant alternative to the costly Western medicine in many rural communities. The problems being faced today include the rising antibiotic resistance against pathogenic microorganisms. Azithromycin is one of the antibiotics which continue to be resistant against syphilis. The high infection incidences of immunocompromised individuals fused with inadequate primary healthcare facilities continue to lead to increased infections in rural locations. And sadly, the transfer of indigenous knowledge from generation to generation and the linkage with scientific communities continues to lack. The aim of my research was to investigate medicinal plants used in the Vembe district by the traditional health practitioners and the local people for the treatment of syphilis. And the objectives were to conduct an ethnobotanical survey on the medicinal plants used for the treatment of Cyphylis, investigate the treatment methods employed by the traditional health practitioners, to investigate the plant parts which they use while preparing medicine, and as well as to investigate the most common plant species used for the treatment of Cyphylis. This is my study area, which is the Wembe district, located in the Limpopo province in the southern side of Africa. Now, this schematic diagram indicates how I conducted my ethnobotanical survey. My ethnobotanical survey was conducted in 6 different villages. To just name a few, I visited the Chiswenda village, the Zanani village, as well as the Mata village, wherein before embarking on my research, a permit as well as permission from the traditional council had to be first obtained. Plants were then collected through the guidance of the traditional health practitioners and identified using the Larry Leach Herbarium at the University of Limpopo, as well as literature. The selected plants were then allowed to dry for approximately 3 weeks at room temperature, cut into small pieces, ground into fine powder, and processed into a decoction as guided by the traditional health practitioners. Descriptive statistics were then used to analyze the data. Going on to the results, the survey revealed 75 plant species which were commonly used for the treatment of sexually transmitted diseases, which happened to belong to 26 different families, with the most dominating plant family being Fabaceae, and decoction being the most preferred mode of preparation of the medication. These are examples of medicinal plants used in the Limpopo province, Wembe district for the treatment of syphilis. The bark of Anthoxylista grandiflora, which is commonly known as moene-ene, combined with the roots of Mimosopsis zaheri, which is commonly known as mububuru, are taken by a patient suffering from syphilis stage 1, which is the appearance of sankra, which happens to be painless sores. Whereas the roots of Asparagus civilans, which is commonly known as Ruparazamakore, and those of Heteromorpha trifoliata, which is commonly known as Mutatavanna, are taken by a patient suffering from, or rather recovering from, syphilis stage 4 as an immune booster. And finally, the roots of Capristomentassa, which is commonly Muabadari, and those of Meru angalensis, which is commonly known as Mutambana Mme, are taken for blood purification. These are more medicinal plants that are used for the treatment of syphilis. The bark of the African tree, Monanga, scientifically known as is taken as a decoction 3 times by a patient who needs to clear up rashes that are appearing and suffering from stage 2 syphilis. Whereas the beautiful yellow flowers of jeka, scientifically known as Agimon mexicana, are dried and crushed and mixed with petroleum jelly and applied directly on gumatosaurs of patients suffering from syphilis. Now, these are more medicinal plants that we need to familiarize ourselves with for this figure indicates the frequency index of plant species that were mostly used for the treatment of syphilis, which happened to be Heteromorpha trifoliata, followed by Anthoxylista grandiflora, Capristomentassa, Alumaloti, and Meru angalensis, respectively. The most plant parts we treatment of syphilis were found to be roots, followed by bark, whereas the least plant parts which were used for the treatment of syphilis were leaves. In conclusion, the Makado community practices the use of medicinal plants for the treatment of syphilis, and the most commonly used plant components to cure syphilis were found to be the roots and the bark, and decoction was the general method of preparation of medication. And then finally, ethnobotanical survey is indeed the starting point for biological assays. In the future, I'd like to investigate the chemical components of different plant extracts, the biological activity of the selected plant species, to test for cytotoxicity assay, as well as to isolate antifungal and antibacterial compounds. Ladies and gentlemen, I would like to acknowledge my supervisor, Prof. S.M. Mahlo, my co-supervisor, Prof. J.N. Ilof, the National Research Foundation for funding, all traditional councils that allowed me to work in their villages, as well as all traditional health practitioners that helped me out through my research. We should all remember that for every human illness, some exists a plant which is the cure. I thank you.
Interesting talk, Trifina. It was really beautiful, and actually it took me by surprise that the traditional healers were willing to give you the formula or way of how they prepare their decoctions, because they are, in most cases, are very secretive about such. So with that, with the future studies that you intend on doing, is testing this decoction, if you still even have it, one of the things that you also add within some of the, I don't know if you're going to add other different solvents when extracting and so forth?
Most definitely. Water, the decoction water is going to be one of the solvents which we're going to use to test more plant extracts.
Okay, and you're going to test the decoction itself, or you're going to redo your own water extraction?
I am definitely going to test the decoction, as well as compare it with distilled water together with other solvents, just to have a good comparison.
Okay. Just we've got some few questions here. So Ariemi congratulated you on your presentation, and he asked, you did mention cases whereby plants were mixed. What are the bases from this as indicated by the traditional healers?
They usually mix them in order to diffuse or to reduce the cytotoxicity of other plants. They may mix plant A with plant B just to reduce the cytotoxicity of the other.
Okay.
As well as I think they all have different users in the immune system that they are probably looking at.
Okay, just to add to the question as a follow-up from Adeyemi, I don't know if it's just going to be an addition of work, but are you also planning on mixing these plants, if you even got a formula on how to mix them from the traditional healers, and testing them also?
Most definitely. I have a very good relationship with the traditional healers that are assisting me. So it would be really remarkable to get results that include a mixture that was mixed by them, as well as what we are also going to do in the lab as well.
Okay. With your relationship, I'm sorry, I've got so many questions here. With your relationship with these traditional healers, then after you test these things, is then the plan, I don't know, to go back to them and inform them of what you found scientifically in order for more work to be done, or do you have any plan within the workings of you and these traditional healers?
Most definitely, it is necessary for me to share the feedback that I've found, even though it's scientific. I believe that there are some things, perhaps, let's say, for example, they were testing roots of a certain plant, and I happened to collected roots and leaves, only to find that they have the same compounds. It would be good for me to go back to them and explain to them that you can actually use the leaves instead of the roots to while treating these illnesses in that regard.
It will take a lot of convincing them, trust me on that one. I'm sure they love using roots. So also Oladayo was also just asking in regards to the plans of testing the efficacy of the decoction as exclaimed. So since you have already given us information on that one, I don't know if there are still more questions. It doesn't look like they are Okay, so I see something from Sam over here. How did you establish such a great relationship with the healers?
Oh well, it did take a quite convincing job to just get them opening up, get them talking. But I started working with them from my honors level, building up to my master's level, and now to my PhD level. Hence, I've been working with them for a very long time. And the fact that I go back and give them feedback each and every time, it's what keeps or encourages them to keep on wanting or willingly assisting me in that regard.
Okay, that's a good one. I mean, those are some of the things that maybe us as researchers need to be taught, because having such a good relationship, you got a decoction out of that. That would mean that maybe if we also just didn't take the information and only use it for our own benefits and never go back to the communities, that means we could have a very good working relationships, both us as scientists and also the traditional healers, because at the end of the day, some of these things that we get from them, majority of the knowledge we get from them is based on history, and they've tested from the past all of these things and found that they are very effective. And also when we come back to do some of these biological assays, we tend to find correlating information with what the traditional healers would have told us. But thank you very much for that. Please do continue sharing some of your expertise in working with traditional healers, because they're really relevant at this point. So thank you very much, Trifina. There are no more questions within the chat box there. We still have some bit of time though, so if anyone is interested in just getting to know more about Trifina's relationship with the traditional healers out there, or some connections that you might need from her, please do engage with her. I think this is a good opportunity. I think from there on, then we can move on to our next speaker.
Thank you.
Yes, thank you so much, Trifina. All the best with the rest of your studies. So, Senorita, are you available? Chauke. Chauke, are you ready for your presentation? Oh, okay, there we go. So our, yes, we can see your presentation. So yes, our presentation is from Chauke from the University of Limpopo, and she'll be presenting on the ethnomedicinal use and antimicrobial activity of potential plant extracts against pathogens using causing ear infections. You can go on the stage.
Thank you. Good afternoon, everybody. I'm Chauke Senorita, as introduced, and I'll be presenting about the ethnomedicinal use and antimicrobial activity of potential plant extracts against pathogens causing ear infections. Herbal medicines are regarded as one of the oldest forms of medical treatment in human history, and they of South African cultures and traditions, and herbal medicines are used by traditional health practitioners to treat various diseases, including ear infections, here in South Africa and other parts of the world. These medicinal plants that are used in herbal medicines are known to have bioactive compounds that produce a definite physiological action on the human body. Ear infections, which are clinically called otitis, the livelihood of people in all age groups, but mostly in children, and they are divided into three categories, namely otitis interna, Otitis media, and Otitis externa. And their causes include a wide range of bacteria, fungi, and viruses that infect the ear. And the symptoms of ear infections include ear ache, ear discharge, and sometimes feeling of fullness in the ear. And there are treatments already in place to combat ear infections, ranging from surgical to medical approaches, such as the use of systemic and topical antibiotics, analgesics, also known as painkillers, acidifying drops, which are mainly used to prevent secondary infections, and antimicrobial drops or oral antibiotics. And the manner of antibiotics that are used can either be of broad or narrow spectrum. The motivation behind the study was the manner in which ear infections affect the livelihood of people, and oftentimes leading to hearing impairment, and in extreme cases, leading to death or facial nerve paralysis. And the fact that some of the treatments that are already in place are expensive, hence we need to find an alternative source that can be quite cheap and affordable by our local people, and the development of resistance to available antimicrobial drugs by these pathogens that cause ear infections, and ultimately to just preserve the indigenous knowledge of medicinal plants in a system that can be accessed by future generations. The aim of the study was to identify the ethnomedicinal plants used to treat ear infections and to determine the antimicrobial activity of the selected plants against fungal pathogens, whereas the objectives were to select and identify ethnomedicinal plant species used for the treatment of ear infections, to investigate the chemical components of different plant extracts, and lastly, to determine the antifungal activity of the plant extract against the selected pathogens, Aspergillus fumigatus and Candida albicans. The plants that were selected in our study were Coprobotus edulis, which is commonly known as Liplomo laconaba, Cotyledon orbiculata, commonly known as Cerulile, and Sansevieria hypsithoides, which is commonly known as Sava. The plant material of selected plants was collected at Bushbuckridge Local Municipality, Mpumalanga Province, and the plants were identified at the Larry Leach Herbarium and using literature. And for plant extraction, fresh leaves were washed and cut into tiny pieces, and then we weighed 40 grams of the plant leaves and used a pestle and a mortar for extraction, and we used 400 mils of solvents of varying polarities, and in this case we used acetone, hexane, methanol, and water. And this below is just a schematic representation of the overall extraction procedure. To analyze the chemical constituents of the plant extracts, TLC plates were loaded with 10 microliters of each of the plant extracts and developed in the 3 different eluent solvent systems of varying polarities, namely EMW, PEA, and CEF. And after developing these TLC plates, we visualized them under UV light. And for the compounds that were visible under UV light, we calculated the RF values. And after that, we sprayed the TLC plates with vanillin sulfuric acid reagent spray in order to visualize more compounds. And the antifungal activity of the plant extract was investigated against Aspergillus fumigatus and Candida albicans. And the methods that were used to test for the antifungal activity of the selected plants, the microdilution assay method was used, and also the Bio-Orthography Assay. So in the microdilution assay, we loaded 100 microliters of each of the plant extracts in triplicates, and also serially diluted with water, followed by loading with the 100 microliters of the fungal culture. And in this case, we used acetone as a negative control and amphotericin B as the positive control. And we incubated them for 24 hours. And after the incubation period, we used INT as an indicator of antifungal activity. And the second method used was the Bio-Orthography Assay, wherein the TLC plates were loaded with 10 microliters of the different plant extracts and developed in the 3 eluent solvent systems, as mentioned, and they were allowed to evaporate under a stream of cold air for 24 hours and again for 48 hours. And after the period wherein they were allowed to dry or evaporate, we sprayed them with the fungal culture and further incubated them for 24 hours. And then after the incubation period, we sprayed them with INT in order to determine antifungal compounds. Our results indicate that acetone extracted more plant material in Cuprobacterium edulis, whereas methanol extracted more plant material in Cotyledon orbiculata and Sansevieria hypsithoides. And these TLC chromatograms indicate the presence of various compounds observed in the different plant extracts after spraying with vanillin sulfuric acid reagent spray. And this table of retention factors it shows the values of the different compounds that were visualized under UV light. And our results of the microdilution assay indicate that the water extract of Cuprobacterium edulis and Sansevieria hypsithoides showed excellent activity against Aspergillus fumigatus, whereas the water extract of Cotyledon orbiculata activity at all against Aspergillus fumigatus, and that the acetone and heg extracts of Cuprobacterium edulis, Cotyledon orbiculata, and Sansevieria hypsithoides showed excellent activity against Candida albicans, but all the water extracts of the selected plants had no activity at all against Candida albicans. Microtiter plates showed the results as recorded in the previous table, with the clear wells showing antifungal activity. So to conclude, acetone extracted more plant material edulis, while methanol extracted more quantity of plant material in Cotyledon orbiculata and Sansevieria hypsithoides, and that Aspergillus fumigatus was more susceptible to the plant extracts than Candida albicans, and that water extracts of Cuprobacterium edulis and Sansevieria hypsithoides showed excellent antifungal activity against Aspergillus fumigatus. So the plants in the study can serve as a potential source of novel antimicrobial compounds that can be incorporated in antimicrobial drug production. I would like to thank traditional health practitioners and the University of Limpopo, including my supervisor, for assisting in this study and making it all possible. Thank you.
Thank you very much, Chauke, for the informative talk that you have provided us with. I have some questions here on the chat. So the first one is from Oladayo. So it's a nice presentation. Maybe I didn't get it in your presentation. How exactly are the plants used by the traditional healers to treat ear infections?
As you can see, the plants that I selected in the study are succulents. So mainly with succulents, what the traditional healers do, they I found that they warm the leaves they heat them, and then after heating them, they squeeze the leaves to release the juices from the leaves, and they use that a liquid from the leaves and just pour it inside the ear. That's how the traditional healers use the plants.
So just as a follow-up question on my side, with the water extract then, did you just use water and extract, or did you boil the plant material and then extract to sort of mimic how the traditional healers use how they use the plant?
We just used water. We didn't boil them, but it's actually something that I would like to do in the near future, since this is a continuing study. And I'm also working on drying the plants, since on this case I was using fresh extracts. I was using fresh leaves. So I'm currently in the process of drying them, and so that I can compare their activities of dry extracts and fresh ones.
Okay. So another question here from Adeyemi, who is congratulating you on your presentation. This question is: you mentioned causes of causes of ear infections as bacterial, fungal, and viral. Any basis for focusing on fungal alone? Are these fungal strains directed, implicated? Is that what you mean? Okay, you can continue and answer that, Chauke.
For this part, I focused on fungal pathogens because they are the most common cause of ear infections, and the pathogens that I selected are the most common under fungi. But I'm also planning to test against bacteria that cause ear infections, such as Escherichia coli and Pseudomonas aeruginosa and Staphylococcus.
Okay, and the viral part?
I would like to also work on that in future, yes, but currently I'm focusing on fungi and bacteria.
Okay, so the second question that Adeyemi was asking is that, are these fungal strains directly implicated?
Yeah, they are, but sometimes ear infections occur as a result of something else, because infections that affect the upper respiratory tract or viruses that affect the upper respiratory tract, they can end up affecting the ear. Whether it's a bacteria or a fungi, it can end up in the ear.
Okay. Here is also congratulating you on your presentation, and the question is, what was the reason for using fresh leaves instead of dried leaves for extraction? I know you did say that you're also gonna look at dried leaves.
Because traditional health practitioners usually use fresh leaves. So that's why I used fresh. But like I said, I'm still going to use dried leaves and compare.
Okay. So Prof. Van Wyk has asked, do you also plan to study anti-inflammatory activity, pain, for instance, pain relief?
Yes, I would like to do that in the near future.
Okay. Floyd here also has asked, has congratulated you on your presentation, and it reads as follows: since you use fresh leaves, do you think the traditional healers have the plant readily to use the fresh extracts? And finally, how are you drying the leaves now?
Yes, they do, because I realized when I was doing plant collections that they do plant these plants in their homes. They do have them readily available, so they can just harvest them and use them whenever they need to. And currently I'm drying the leaves in room temperature.
Okay, so just as a follow-up question, if you're saying that they do plant them in their own homes, are these plants actually, I know that you had mentioned that they're succulents, are they available throughout the season? And then the question again will be that, are they not going to have issues with seasonality within the phytochemistry and their efficacy?
from what I've observed, they have the plants throughout the seasons since they plant them in their homes, so they water them anytime. They don't really die out. So yeah.
I mean, it will be very interesting then because what the different seasons might have an impact on the phytochemistry and even the activity of the plant. So if they are just used throughout the season, it's something that people might have to, or you might have an interest in looking into. Seasonality-wise, do you still find similar activity throughout the year when you're looking at this, the efficacy of these plants?
That's actually an interesting fact, and I was thinking of that the past few days. I would like to also look into that and compare the phytochemistry in the different seasons.
Okay. So thank you very much, Chauke. So I don't see, okay, let me just check. I don't see, okay, there is another question that comes here from Ida. So it's for C. endulis, takes weeks to dry under room temperature. Rather try heat drying at 40 degrees.
Okay, thank you so much. I'll definitely give it a try.
Okay. Yes. So, okay. From that, since I don't see any more questions, okay, there is another one. Oh, freeze drying. That's another suggestion from Floyd.
Okay. Thank you so much.
Okay. Are we coming up with anything again? Going once, going twice. Okay, so thank you very much, Chauke, for your great presentation, and thank you again for keeping to time, and all the best with all the work that is still ahead of you that you intend on doing, or that you can even pass to other people that follow. Thank you so much. Okay. So our last speaker of the day is Tato. Tato, are you with us?
Yes, I am here.
There we go, Tato. So Tato is from the University of Wits, and he will be presenting.
You got cut off there.
Oh, okay. Sorry, my network is giving me some bit of issues there. Are you able to hear me now?
Yes, we can.
Okay, so Tade is going to be presenting on the effect of elevated carbon dioxide on the phytochemical profile, antioxidant and antimicrobial activities of moringa species. This is a comparative study that he is looking at. When you're ready, you can share your presentation and go ahead.
All right. Can you see my study? My screen? Can you hear me?
You can continue.
Oh, okay, sorry. Good day, ladies and gentlemen. My name is Tato Moloi. I'm from VETS, and I'm gonna be presenting to you my study that I was doing last year. My talk the effects of elevated CO2 on the phytochemical profile, antioxidant and antimicrobial activity in Moringa oleifera and Moringa peregrina. I'm being supervised by Dr. Ida Risenga, Dr. Charlene Duken, and Mr. Philemon Ramalepe. I'd like to kickstart off things by talking about climate change. As we all know, climate change is the long-term alteration in our weather patterns and also our temperature patterns. This is mainly caused by the large accumulation of the greenhouse gases within our atmospheres. These greenhouse gases are mainly caused by anthropogenic activities, such as burning of fossil fuels and our large growing population in the world. So there's a higher energy need or demand, thus the higher greenhouse gas accumulation in the atmosphere. For this study, I'll be focusing on CO2 specifically. In South Africa alone, there is a high reliance on coal. As we all know, Eskom is using coal for our energy needs, and this releases a large amount of CO2 in the atmosphere. Currently, South Africa is the #1 emitter of CO2 in Africa, and this have prompted researchers to estimate a 4 degrees to 6 degrees Celsius increase in temperature in our near future. This increase is very high when you consider the global increase, and it is not very good for medicinal plants, because medicinal plants have enzymes that are used, the enzymes that are mainly used to synthesize phytochemicals with medicinal properties. So if this high temperature change were to occur, there might be a denaturing of some of these enzymes, thus impacting the medicinal properties of medicinal plants. Currently, the CO2 concentration in the world is 415 parts per million, and it is predicted to be around 600 parts per million by 2050 and greater than 800 parts per million by the end of the 21st century. As I've mentioned before, this high CO2 increase brings about a lot of changes, and some of them are positive and some of them are negative. Some of the positive changes is that there is an increase in biomass with an increase in CO2, as we've seen in literature. And there's also some medicinal plants that have increase their secondary metabolites accumulation when you increase the CO2 concentration. And the drawbacks of the high CO2 is that there is decreased longevity of the leaves, meaning the leaves turn yellow quickly due to carbon toxicity. And there is a decrease in nutrients in the nutrients of the crop or the medicinal plants, because now instead of having all those nutrients taken in by the plant, you substitute them by taking in a lot of CO2 and not a lot of those other nutrients. So crops tend to be less nutrient as you increase the CO2 concentration. And also I've mentioned the decrease in medicinal properties or capabilities of plants. Continuing with my introduction, I'd like to talk about the Moringa genus. The Moringa genus, as we all know, belongs to medicinal plants, which are plants with exceptional medicinal properties, or phytochemicals that have medicinal properties. They fight off diseases, fungi, and a lot of different ailments that people have. So Moringa genus belongs to the family Moringaceae, which consists of 13 species, and it is native to Asia. But due to its medicinal properties and nutritional benefits and its ability to be grown in a wide variety of varying conditions, is now cultivated throughout Africa, Madagascar, South and North America, as you can see by the distribution map below. I'd like to also talk about the 2 species that I'll be working on, which is Moringa oleifera and Moringa peregrina from the Moringa genus. These 2 species are different, but there are some similarities between them. So I'll start off by the similarities. So as I've mentioned before, they belong to the Moringaceae family. They both have exceptional medicinal and nutritional properties. They both grow well in hot regions with well-drying soils, and they both possess identical pharmaceutical compounds. By pharmaceutical compounds, I mean basically secondary metabolites such as phenolics, flavonoids, saponins, and so on. So they both possess those compounds. The differences is that Moringa oleifera, it is widely studied. It is the most studied species in the Moringaceae genus, and thus there have been discoveries of it having more uses per part of the plant. By this, I mean like we all know the leaves have a use, the bark have uses, the roots have a uses, the seeds have medicinal uses, and also its flowers have uses. When you compare it to the Peregrina, on the other hand, where the flowers, we don't know if they are being used or not, but all the other parts have uses. There are also plant structural differences between the two. You will see in the following slide, and also the seed oil content is very different between the two. Peregrina has a higher seed content when compared to oleifera. Here are those plant structural differences that I was talking about. As you can see, first, let's talk about the flowers. Moringa oleifera has a yellow white flower, while Peregrina here has a white pinkish flower. The seeds are also very different. They are winged for oleifera and they are very smooth for Peregrina. Their pods are also different and their leaves are different. So they have the same compounded leaves. The difference is that when the Peregrina matures or when it is about to bear pods, it sheds off all its leaves, as you can see in structure P. But the leaves are the same as oleifera. It's just the Peregrina, they are a darker shade of green. Okay. So my research aim was to investigate the effects of elevated CO2 on the phytochemical profiles and the biological activities and secondary metabolites in both species. So my objectives were to assess the phytochemical compounds in the leaves of both species under high CO2, which is 600 and 800 parts per million. Another objective was to determine how elevated CO2 impact the antioxidant activity of both species when compared to the control, right? And also lastly, I wanted to compare the results of the control to those of the treatments. My research methods goes like this. This is the order in which I conducted my study. So firstly, acquisition of seeds. The seeds were for oleifera. I got the seeds in a moringa farm situated in Hammanskraal, just north of Pretoria. And for Peregrina seeds, I purchased the seeds from Tabuk University in Saudi Arabia. The next step was I potted the seeds and then I incubated them in an oven under 37 degrees Celsius until germination. After germination, the seedlings were transferred to the greenhouse so they can grow under normal conditions or ambient conditions to acclimatize. And then after that, they were transferred into the convirons to start their treatments. The settings for the convirons are as follows. For the CO2 concentration, I had 400 parts per million, which is our control, 600 parts per million, and 800 parts per million, which are the two treatments. The relative humidity was set at 60%. The temperature ranged from 25 degrees to 28 degrees. 25 degrees was at night, so after 7 p.m. until dawn. And then it steadily increased from 25 to 28 degrees during the day. Next, during the experiment, the seeds were watered every 3 days for 3 months. And then the harvesting process. So I harvested the leaves of the two species after 3 months. I air dried them and then I grounded them into fine powder. And then the extraction process was done using 80% methanol. And then we filtered the extract. Using the extract, I did antioxidant activity test, So under we use the color test analysis. Different methods with different instructions and chemicals are used to see if there is a presence of a particular compound you are looking for within that extract. So a color change will indicate the presence of that particular compound you're looking for. If it doesn't change, then there is no presence. The darker it gets, the color change, the more concentration of that compound there is in the extract. Under antioxidant activities, I did 3 tests: DPPH, hydrogen peroxide, and metal chelating. We then used a spectrophotometer to measure the absorbance after adding the extract to the reactant. For the antimicrobial test, we used a disc well diffusion method where 6mm disc wells were pierced and then injected with 100 microliters of the extract. We grown 3 species, which is the gram-negative E. coli and 2 gram-positive bacteria, which are the S. aureus and S. albulus. The incubation period was 48 hours, and then it was taken out and measured for zone of inhibition using a 20-centimeter ruler. Results and discussion. I'll start off by the phytochemical profiles. Starting off with Moringa oleifera, we can see that when you increase the CO2 concentration from 400 parts per million to 600 parts per million, we see a increase in the accumulation of the secondary metabolites in the leaves of the species, right? And when you further increase their concentration to 800 parts per million, we can see a decline, not a very drastic one, but there is a decline in some of the secondary metabolites also disappear. For example, as you can see, the second row, the saponins, they disappeared for under 800 parts per million when you compare them to the increase under 600 parts per million. The trend also follows for Peregrina. It's just that we didn't see any disappearance of the secondary metabolites under 800 parts per million. We just like seen a decline in the accumulation when compared to the 600 parts per million, right? For antioxidant activity, this is the IC50 graph. We can see the control has a very moderate or good scavenging activity capabilities when compared to 600 parts per million and 800 parts per million, right? The difference we found to be significant for all the graphs. And for the hydrogen peroxide test, we can see the same trend. For the control, we can see they are fairly doing well. And then when you increase the concentration to 600 parts per million, you can see a decline in the antioxidant activities. And when you further increase it again, Peregrina seems to be regaining its antioxidant activity proudly, but oleifera, unfortunately, is struggling. Same thing under for metal chelating. You can see the control is doing great, and also followed by the 800 parts per million, and lastly, the 600 parts per million. Right. One thing to notice, what I've seen in the greenhouse during the experiment was that Peregrina might be doing well here because it was fairly robust, or it was fairly robust under the high CO2 treatments, meaning it didn't reach the yellowing of the leaves as soon as oleifera did. For example, it took approximately 28 days for the leaves to start yellowing, and then even shorter, under 800 parts per million for oleifera, while it took an extra week or two for Peregrina to start yellowing its leaf to start feeling that stress of high CO2. So for antimicrobial activity, starting off by E. coli, we can see the zone of inhibitions below in the table. The concentration used, as I've mentioned previously, is 100 microliters, which was injected into the disc wells. So for the control, we can see the Peregrina also here doing fairly well in E. coli, against E. coli, sorry, and then followed by Olivera, which didn't have as much as, it is good, it's antibacterial activity, but not great when compared to Peregrina. Staphy also, as Urus, see same trend here. Peregrina fairly doing well with 800 pulling way ahead over Olivera. As you can see, the zone of inhibition was 23 millimeters compared to 17 millimeters. And lastly, we see the S. albulis, also here same trend, but not as much significant difference, but also Peregrina doing fairly well in coping with the bacteria against Olivera. Here are the pictures to show you how it was. Urus, as you can see, the zone of inhibition for Peregrina is larger than that of Olivera. The trend also increases, as you can see here. The zone of inhibition is very large when compared to that of Olivera, and etc. So, in conclusion, what did I get from my study? I saw that when you increase the CO2 concentration, both species show an increase in phytochemical accumulation under 600 parts per million, and then there will be a decline in accumulation in 800 parts per million. Peregrina shows improved antioxidant capabilities when compared to Olivera for the control and for the 800 parts per million treatment in terms of antioxidant activities. And then all bacterial strains are moderately sensitive to the Olivera extract, whilst they are sensitive to Peregrina extract besides S. albulis. Further studies are needed to quantify the phytochemicals in each study. By this, I mean I have to use chromatography to not only see if there's an increase or a decline in the accumulation, but also see which component is increasing and which is not, which might tell us more about the activity that we're seeing for antimicrobial and antioxidants. Thank you. Any questions?
Thank you so much, Tato. Interesting presentation, actually. So, I mean, these two species are showing some bit of differences there. I think before I continue with some of the questions on the chat, which are really mounting up here, my first question is the distribution of both of these species. Is there any overlap or what? Because when you're looking at the stress tolerance, there's some bit of differences there.
In their native continent, there is not much overlap because I know Peregrina is mainly in the south region of Asia, while Olivera is at the top and like at the center. So at Asia, there is not much overlap besides maybe cultivation, where you might be interested in, growing the other species, but natively, I don't think there is any overlap of the two species.
Okay. I see there. And so let's start with the chat. Let's continue with the chat. So there's a question here on, was it fairly easy to import the seeds from overseas?
It was because it was before lockdown, and also my supervisor has relation with a professor in the university where we bought the seeds, so it was not as a hassle to get the seeds per se.
We seem to have lost Kobile. I'm just going to go to the next question, or you can see it in the Q&A, Tata. So it says, some people consider, I don't want to say it incorrectly, Moringa SP potentially invasive. Do you think the benefits outweigh the potential negative impacts?
Yes, I think so. Firstly, I don't think, besides maybe it's, I don't think it is that much.
Yes, sorry, I just lost some connection there. You can continue.
Oh, okay. I think the benefits outweighs definitely the environmental impact of the two species. It is invasive because it's not really from Africa per se, but because it has nutritional benefits and also medicinal benefits, and also people can make a living out of it, maybe like selling the oil to cosmetic industries and pharmaceutical industries. I think the benefits outweighs the environmental impact. It is not as heavy impact. It is not impacting heavy as some of the tree species, which are also invasive, but it is once again invasive, and I think their benefits outweighs the environmental impacts.
I think I'll go to the, because I see you've answered another one. So Oladayo says, interesting presentation. Did you consider or monitor the length of the light or dark period since the plants were grown in controlled environment?
Yes, I did. The lighting intensity was set to be at level 1 for the confinement settings, or also 140 nits, which is the brightness of the street light outside, basically at night. So we set the time to be the same as the time outside, where around 6 a.m. the lights will come on and slowly increase in the 7 p.m. where it will just shut down and be dark, just like the temperature.
Okay, another question here from Adeyemi, who says, any indication of trade-off between the growth response versus phytochemicals and biological activities?
I feel like there is a trade-off because the tree does grow bigger leaves, but it's not as strong as the one that you would grow outside the tree in terms of its physiology. It is not as robust because now it's only focusing on putting resources into growing the leaves and not on maintaining it to stand maybe some of environmental factors that you see outside. Also, the trade-off in medicinal properties, it depends on whether you see an accumulation or a decline. Because if you increase the CO2 above the level the plant can handle, it will start to die off, which they did. I did leave them. I did leave them for extended periods over the 3 months that I did my study, and then I did see that they, after that that period, they started to actually die off and not produce any more leaves per se. Its medicinal properties, I feel like it is dependent on the concentration of the CO2 levels that you set, but under high CO2, it depends on which species you are using. As I've said, Peregrina seems to be doing better for higher concentrations of CO2 because it is more robust under those conditions when compared to Oleifera. While Oleifera is mainly doing better under ambient conditions, maybe that is why it is very famous and widely cultivated.
Okay, so a suggestion here from Adeyemi, who says you may consider to use the micro dilution for antimicrobial tests due to inherent challenges with agar diffusion method. Yes, a question here from Sam is that I'm sure you mentioned in the beginning what CO2 levels to be expected with climate change.
They are predicting a increase of 600 parts per million, that will be sitting at 600 parts per million in 2050, and then it will be above 800 parts per million when at the end of the century, 21st century. If nothing is done, that is, if there is no change in how we are living or how we are using our energy consumptions, our meat consumptions, and all those that are contributing to their greenhouse gas emissions.
Okay, thank you very much, Tato, for such an interesting presentation there. I don't see any questions again on the chat. So I'll have to say that thank you and all the best as you continue with some of your work. So with that, I'm not sure how my network is going to be because I've been having so much problems with it now. With that presentation, then we are finalizing a session on ethnobotany and all the presentations. Thank you very much to all the presenters. They did a great work as we had seen, and they all actually kept to time, which was very great. It shows that they'd done preparation and also timing themselves, and it was great to also hear the answers and also some of the suggestions that have come into play that some of our presenters can also look at in future as potential work to be done as part of their degrees or even as side projects to be considered. So if I'm not mistaken, and the organizers can let me know, I think it's supposed to be Prof. Osnell that is supposed to come through. There we go.
I'm here.
Okay, thank you very much. Over to you, Prof.
Thank you, Doc. Yeah. Good afternoon, colleagues. I have made a nice observation. Yeah? In most cases, when the conference is heading towards the end, people usually get tired. But it was opposite in this sub-conference. There was a lot of energy towards the end. And when I compare the sessions, I see the one by Dr. Masondo. There were a lot of questions for the presenters. And I'm sorry for Tato, I think being the last one as well, you were bombarded so much. But thank you very much for attending to the questions quite well and eloquently. I think let me start by thanking the sessions for the day for today before we round up for the whole conference. I would like to thank all speakers for today, which is our last day. These speakers include our plenary lecture speaker, which is Dr. Ngara, and all the breakaway session speakers. I think you presented wonderful talks to us today. They kept us alive and also occupied for the day. So thank you very much for such a contribution to the conference. I also would like to thank the listeners as well. I think your contributions were very useful and immense. In terms of the questions that we're answering, you were asking, actually, they were very relevant to the presentations that were given, and comments that were also posted in the chat box. It was quite awesome. I also would like to thank the parallel session chairs, or the session chairs for today. There were three. First of all, we had a parallel session, one which was being chaired by Prof. B.E. Van Beek, and the other one by Dr. Lizel Jobet. Then the last one now by Dr. Nobile. So, like what I said, there was a lot of energy towards the end, and probably for Dr. Nobile, because all of us were in one room. Initially, most of the sessions were parallel, so we'd have the other side, the other half, the other side, but now we're all together. There was a shift and a difference in the way the sessions were going through. So maybe it was because we're all in one room. I would like to thank everyone for attending this conference, because today is our last day. We've come now to round up all the talks. We've finished all the presentations. Most of the activities have now been rounded up. So I would like to thank all the delegates who made effort to come to attend this conference, although it was virtual, but we managed to create time and to commit our time since Monday until today. For almost the whole week we were here, and we managed to listen, we managed to contribute, we managed to share ideas with others. It was awesome. The amount of energy that we have now, I thought we were supposed to extend this conference for another extra day tomorrow, because it seems we're gaining. Even the interactions that we're seeing in the question and answer, boxes there, or from the presenters, there was a lot of confidence now as compared to what was happening on Monday or Tuesday. Today, it was a different day, and I think we're gaining and getting used to the system. So thank you very much for attending the conference, and we are happy that we managed to come to the last day and everything was going on. But all this could have not gone well without our technical team. I was happy the way they were working, even behind the scenes, with our own WhatsApp group that we were working on, behind everybody, to make sure that we control everything. And they were also communicating through emails with session chairs and everybody, to make sure that everything is done. I could see that even presenters could be swapped around, and there was no problem. Even if one was put as the last but is asked to start, everybody was just ready to give the talk, which I think we were fully prepared for the conference, and I'm happy with that. I also would like to thank the organizing committee for this conference. I think having it as the first one for SAAB under these virtual, conditions, I think you did extremely well, because we didn't have any benchmark to say we are matching it with something. Maybe next year, if we do it virtually, we'll be comparing to what we did this year. But for the first time, I think if you look at the trend in the manner in which the conference proceeded, this is excellently well, and we are happy about that. And I think the organization on its own was good, and then the management of the whole process was also awesome. I also would like to thank the SAAB president and her council, I think, for giving us this opportunity to have this conference under these circumstances, where we had to sit on our laptops and listen to each other. I think it's a good opportunity that you gave us, and we thank you very much for that. So in a way, I think for the 4 days that we were together here, I hope it created a lot of opportunities for all of us. Like what Dr. Nobila was saying just before I came in, I think for researchers, from the various presentations that were given, the various topics that were studied, we can also pick up new insights, which we can also use either to improve our current research, or even come up with new areas of research because of what we listened to here and benefited. At the same time, I think all of us, there's a possibility of also creating new collaborative links with each other here, either for research, or even we can get people for external examination of your postgraduate students, or to co-apply for funding. looking at the various work that is presented here, you can find somewhere where you can fit and then work with others to either get some funding, some research funds, or to do some collaborative work. So we need to take advantage of this conference. At the same time, I think for postgraduate students, and I saw most of you in huge numbers here, those who are still at honors level, master's level, even PhD level, there is a great opportunity now to get new supervisors or new labs to go and work in, or new research areas to go and work in. You can go and do a postdoc by just linking to someone here, because we are one family here in the SAAB. And also, you can also go and do your PhD in any of the labs, or go and proceed into your master's from honors. So all these opportunities, I think, have been created because we committed our time and our efforts to this conference. So overall, we are happy that we have come to the end of the actual proceedings of the conference, but we still have some few activities to do after this. So from here, we have a short comfort break until 5:10. I think we've already passed it now. There's an annual general meeting. There's a new window that has been created. The way that we're choosing either session 1 or session 2, when we're doing parallel sessions, you can see there's a new room that has been created for the AGM. So for those who are qualified to get into that meeting, please go and join in. You just go and link, just connect the way we're doing before. Then after that, we'll come back now to give some hours. But to me, I'm saying all of us were winners because we managed to do everything together. So that one will come back to the main room where we are right now after the meeting. Then we will finish off the whole day. But at the moment, most of the basic conference activities will now come to an end. And thank you very much again for your time and for your commitment to make sure that we completed the whole 4-day activities. So I will stop here and wait until we meet again for the prize giving. And for those who are going for the meeting, please go ahead and enjoy the meeting. Thank you very much, and God bless.